Today we're going to be talking about inequalities and how those inequalities are going to relate to geometry. So suppose that we are given an angle, and our angle AXC, the bigger angle, we know adds up from the smaller angle AXB and BXC. So we know that by the angle addition postulate, the biggest angle is the sum of two smaller angles. So therefore, what's the relationship between AXB, the smaller angle that's inside of the bigger angle AXC, in relation to AXC? Since AXB makes up part of a larger angle AXC, we know that AXB has to be less than AXC. And same thing with BXC. Since BXC adds up to make up something with the bigger one, we know that that is also less than. And lastly, AXB and BXC. I can't tell the relationship between those angles. So here, we're not sure. There is no conclusion. Okay, all of these are the properties of inequalities that we are going to be working with this year. And so if you have two things where A is bigger than B and C is bigger than D, or equal to, when you add them together, you're still going to have something that's bigger. Same thing when you're dividing, but C has to be greater than 0. A fancy way of saying that is a positive number. So whenever I divide an inequality by a positive number, I leave the inequality sign as is. But when here we divide by a negative number, then notice how the sign switches. And that's just, you remember your rules from algebra. If A is bigger than B, so 3 is greater than 2, for example, and B, which is 2, is greater than C, which is 1, therefore A, which was 3, has to be greater than 1. Just put that in terms that you can understand. And then this was that property that I just talked about. So if B plus C, so two things, whether they're segments or angles, add up to be a larger thing, and C, or technically B, don't equal 0, then A has to be greater than either one of those, B or C. Okay, exterior angle theorem. The measure of an exterior angle of a triangle is greater than the measure of the remote interior angle. So, okay, let's look at this. This says that the measure of the exterior angle, so angle DCB is going to be greater than either of the interior angles, so greater than angle B. And also angle DCB has got to be greater than angle A. Okay, so let's look at why that is. Why is that? Well, that's because angle DCB is equal to the sum of A plus B. So by that previous property, we know angle A plus angle B, by our triangle exterior angle theorem, A plus B equals the exterior angle. So therefore, DCB, the exterior angle, has to be bigger than either one of those two inside of it. Okay, our proof. And please make sure you have this proof written down. Okay, so our proof. First, as always, we start out with our given. Okay, so next, let's look at what we're trying to do here. I'm trying to show that XRT, this angle here, is greater than angle S. Well, think of how XRT is in relationship to all of these other angles. Well, XRT is greater than angle T. So let me write that down. Angle XRT is greater than angle T, because that is our triangle, our exterior angle inequality theorem. Now, if I could get angle T equal angle S, that's going to help me out. So, let's look at what we have. QR and TS bisect each other. So I know that V is the midpoint. Of ST and QR. And that's definition of a segment bisector. Next, since V is the midpoint, QV is equal to VR, and SV is equal to VT by definition of a midpoint. All right, now let's put in some angle measures. I have angle 1 and angle 2. Angle 1 is equal to angle 2 because vertical angles are congruent. Next, I know that triangle QVS is congruent to RVT by side angle side. So therefore then I know that angle S is congruent to angle T, which then that helps us get what we want. Because if you remember back here, we knew angle T was greater than XRT. So therefore, that's going to help us get our proof of angle XRT being greater than angle S because of substitution. Okay, there are your lesson questions. Determine whether each statement can be deduced from the information given. And what you're going to be writing is you're going to be writing, I think I'm actually going to have you guys clicking either yes or no. And please make sure that is submitted on time.